Hi everyone, this is Mr. Will from Optovision with Mr. Will. I'll discuss another question from Okasa. So this is the second question. Still on the topic of bearing and distance. A ship sails 50 km north from a point A. So let's draw this on a sketch. It travels 50 km north. So that's going to be 50, and then 25 km west. So it travels to the left for another 25 km, since west is in the left direction. And finally 50 km on a bearing of 315 degrees. So let's draw the bearing on that last location, my north. We're going to draw a clockwise direction from the north for 315 degrees. 450 km. So this angle is 315 degrees. For the first question, how far west is the ship from the point A? We want to know the location of this last point with respect to the initial point A. Part A is asking how far west, which is just the horizontal distance of that point from point A. And part B is asking for how far north. So basically it's just the vertical distance of this point to point A. To help us to solve this, I'm going to draw a simple sketch. So I'm going to draw a vertical line from the last point. And I'm also going to draw a horizontal line from the horizontal distance of that point to A. For part A, how far west basically is just going to be this length. Right, so this is the horizontal distance. And for part B, it's going to be the vertical distance. So how far north is just this vertical distance. We're gonna solve part C later on, but let's start by solving part A first. The part A, we can actually draw a simple triangle, maybe just to help us see this clearer. I'm gonna draw another line from here, and then you can actually see that this triangle, we can see there is a triangle here. This triangle is perpendicular at this point, so it's just a right angle triangle. That angle is just 315 degrees minus from the north up to this line is, which is 270 degrees. It's 315 degrees minus 270 degrees, which equals 45 degrees. So this is 45 degrees. If we have a right angle triangle, that one of the angle is also 45 degrees, so that means this is going to be 45 degrees. So this length is equal to this length. Basically, this is just an isosceles right angle triangle. So let's solve this. How far west, which is this horizontal distance, which is A, we can actually divide the length into two parts. We know that this is 25 because the length from here to here is the same as the length from here to here, which is 25. And then the other one is this base of this triangle. We can use simple trigonometry. So this base, 50 sine 45 degrees. How far west of that last point to the point A is 50 sine 45 degrees plus 25. And sine 45 degrees is half square root of 2 Then we have 25, 50 times half, 25, square root of 2 plus 25. If I factorize the 25, that's just square root of 2 plus 1 kilometer. For part B, so how far north? Basically the vertical distance. Same thing, we can divide this into two parts. This length is just 50. The bottom length is just 50 because the length from here to here is the same as this, which is 50. And then for the top part of B, since this is the same length as this, so we're gonna have the same value, which is 25 square root of 2. It is equal to 25 square root of 2 plus 50. If we factorize the 25, that becomes square root of 2 plus 2 kilometer. Now, let's solve part C. Part C basically is asking for the distance and bearing of the ship destination, which is the last point, from A, right? So we want to find the last point, part C. If we want to use a line just to help us draw this, it's just this distance. It's just this distance. Okay? That length, we can use a simple Pythagoras. The base square plus the height square and then square root of that. So that's going to be that distance. It's just the square root of 25 square root of 2 plus 25 square plus 25 square root of 2 plus 50 square. If we just calculate this approximately, round off the three significant figures, that's going to be 105 kilometers. What about the bearing? We would like to find the bearing also. We draw the north direction. The bearing is just from the north in the clockwise direction until this point. If we can find the value of this angle. So let's name it as theta. We can find the value of theta. We can use inverse tangent of the opposite side, which is the horizontal distance, over the adjacent, which is this vertical distance of this big triangle, right? So that's just 25 square root of 2 plus 25 over 25 square root of 2 plus 50. We can actually calculate this again using calculator. That's going to be 58.2 degrees. So the bearing from our final position to where A is just going to be the straight line angle 180 degrees minus the theta, right? So it's 180 degrees minus theta, 180 minus 58.2, 122 degrees. So that's the bearing using 3-digit figure. We have solved this question. Again, until the next question. See ya. Cheers.